Assalamualaikum and good day, everyone. So, this is a short lecture or briefing regarding towards preparation for fluid mechanics lab, especially to those who have not taken fluid mechanics subject beforehand. So, for this lab, we have two tasks. The first one regarding flow rate, and the second one regarding Pascal law and pressure intensification. I'm gonna explain first on regarding. First, I will explain on task one regarding the flow rate concept. So in the lab sheet, you can find these short notes regarding flow rate. Even though you have not taken fluid mechanics subject, but I believe you should have learned this in your physics subject, either during your foundation or SPM. I guess it's pretty direct, straightforward. Flow rate is actually um, the the amount of volume, the amount in terms of volume. For example, water um, that is passing through a certain point over a period of time. So that's why from here you can see the formula is given by volume divided by time. Okay. For a very simple analogy, you can imagine that you have like uh, like this bottle container. So we know that the capacity is 800 milliliter. Okay. So 800 milliliter, and then it's originally is empty. So I'm gonna so if you open your tap water, and then the amount of time taken for the water to fill in this water bottle until it's fully occupied will be recorded. Let's say it takes around 10 seconds for the water to fully fill in this bottle. So we know the volume, the full capacity is 800, and then we divide with 10 seconds. And if you solve this mathematical equation, you will get how much is the flow rate, and the unit will be in milliliter per second. But normally we assign the unit in either liter per second or liter per minute. So in the during the experiment, what you are going to do is so basically you can see this is the measuring tank with the scale to measure the volume. So yeah, if you read the procedure carefully, you will see that you are going to set for every 10 seconds how much in terms of the volume of the oil, because we are using hydraulic system, so we are using oil, no more water, it's oil. So you can within 10 second, so within 10 second, how much is the volume of the oil being trapped. And then when you know the volume and then you know the time, so you go back to the same example that I've shown you just now. Okay. So you have this component. It's like the valve that you want to open or close to allow the oil to go to the tank. Okay, so this is to on or to off. And one more, you can see that you have this flow control valve. So this is the valve where you can set how much is the opening of the valve, which will vary the amount of the flow in terms of volume that will go to the tank, to the measuring glass. Okay. Therefore, in the table, you can see that you are going to play around with the number of turns of this FCV. So you are basically going to from the fully loose until you fully tighten, and then you will see you should get different value in terms of the volume measured within the same period of time, which is 10 seconds. And for the first round, you are going to use to set the amount of pressure for the system to be 25 bar. And then once you are done with this first round, you are going to repeat the same measurement, but you are going to increase to double up the pressure to 50 bar. So that's basically for task number one. And for task number two, we are actually looking at the pressure intensification using Pascal law. So in fluid mechanics or in physics, Pascal law is pretty basic. So we know that the key formula for Pascal law is the pressure is actually equal to the force divided by area. This is the basic formula. All right. So we have this we call as a hydraulic cylinder. Okay. So you have the piston here, and then you have piston rod having a certain value of diameter. So it's given here. The diameter of the piston is 2.5, which is the whole diameter here, or this one. Okay. This is the P. Sorry. Okay, different color, yellow. Yeah, so this is your DP. And then this is your rod diameter, DR, is given. Okay, so the thing is, we supply the oil going to this, let's say we supply the oil going to this port. So what will happen in this region, or we say that on the piston base side, the area having intact or having in contact with the oil is actually this whole piston area. Meanwhile, on the other on this side, on the piston rod side, when you have the oil inside, the oil is having contact with only this area. It looks like a ring or a donut. So, and this area is given by the total piston area minus this small rod area. Okay, by the way, don't get confused with this R. This R means refers to ring. Okay, and another R here. So maybe it's better to just label in full word A ring and A rod so that you will not get confused. So the area corresponding to the other side is A ring, which is this area. So because of, when we go back to this formula, so we know that the area is different between this one and also this one. And during the experiment, you will be asked to, of course, you have to read one by one, and there will be a specific instruction where you need to get the cylinder to be in equilibrium. Okay, when the cylinder is in equilibrium, this is exactly the figure of cylinder in equilibrium. So during this time, when what we mean by equilibrium means the force on this part, which is we call it as extension force, is actually equal to retraction force. This one. So when the force is the same, and from this Pascal formula, we can rearrange that since P equal to F divided by A, so we know that F equal to P times A. So F extension refers to okay, and refer to, we call it, this pressure here is as P1. Okay, so the extension force equal to the pressure here P1 multiplied with AP, which is the full piston area. And then for retraction on the other side, we assign this as P2. Actually, P1 and P2 is coming from here lah. The one that you can see, the value shown in this manometer will be, this one will show you value of P1. This one will show you value of P2. So back to this one. So for F retract equal to P2 times ring area. So when we rearrange this, we finally will get the pressure P2 here is actually equal to P1 multiplied with the ratio between area AP and AR. So RA is actually equal to AP divided by AR. So if you understand the concept of ratio, and we know that physically, we know that AP is actually larger than a ring. Okay, even from the visual, you can see the full piston area versus the ring area. Of course, piston area is larger. So when you have the larger values, the larger value divided by smaller value, of course, your ratio will be some value of greater than 1. So when you multiply P1 with any value of greater than 1, you should get your P2 to be larger than P1. So that is what you should expect from your experiment. So basically your P2 is here, given by the value of shown by M2, and P3, sorry, this is your P1 lah. Okay, this is P1 and this is your P2. If you want to match this circuit with the concept here. Okay, so M2 will give you P1 value, M3 will give you P2 value. Right? So basically this will be your this will give you your P1 value, this will give you your P2. So this M3 or P2 should be larger